There are just too many strange and odd little creatures in our world for us to not talk about them on a regular basis. Stick around and we'll visit all of them, one species at a time, using some of my semi-accurate sketches. Welcome to Sketchbook Biology. I'm Rue, and I'm a biologist in training, and I'm your host. This week, we travel to the toasty deserts and grasslands of the American Southwest to step into the world of a spiky little pancake that shoots blood from its eyes. Think small, flat, short limbs, blunt snouts, spiky, and built like a tank. We're going to be talking about Phrynosoma cornutum, the Texas horned lizard. These guys are usually no bigger than your hand, with rough, desert-colored skin with some dark spots and a pale racing stripe along its back. Two elongated horns crown its head, with more lining its jaw, and along its flanks, you guessed it, rows of sharp spines that separate the larger spikes of the dorsal side from the scaly underbelly. I know. If you haven't had the joy of seeing one of these guys, all those spikes, they might sound a little intimidating. But they look so baby, so adorable. That being said, do not the baby, at least in Texas. They are the state animal and a protected species. It's illegal to handle, own, or sell them. However, their native range stretches across the southern US and into Mexico. You can spot these lizards from Colorado to Missouri, down through Texas and Oklahoma, all the way into northern and central Mexico. They've even been spotted as far west as Arizona and New Mexico. These lizards make their home in dry places, with plenty of open space that contain plants like bunch grasses, cacti, yucca, mesquite, and acacias. You'll find them in prairies, sand dunes, deserts, and near dry basins that occasionally catch the rain. Until late March, they'll be tucked away in their burrows in loose sand, loamy soil, or even later fall, hibernating through the cold. And when it finally starts to warm up, it's time to wake up and rustle up some grub. Actually, grub's the wrong word. It's time to rustle up some ants, and one specific type of ant. The Texas horned picky eater is an insectivore and predominantly feeds on the red harvester ants of the genus Pogonomyrmex, but they'll throw in a termite, a beetle, or a grasshopper every now and then for variety and if the opportunity presents itself. Most mornings, a Texas horned lizard will roll up to the closest ant colony and park at the entrance and stand very, very still, waiting for the buffet to open. As soon as the ants clock in for the day, out come the lizards, very fast, very accurate, and very sticky tongue, and bam! Breakfast is served. One of these little guys can scarf down anywhere from 30 to 100 ants a day. Now, this diet in itself is fascinating because harvester ants both bite and sting, and this sting just happens to be highly venomous. These ants come equipped with crushing mandibles, and the females have a venom-injecting stinger at the tip of their abdomen. That's not to say that the males don't have stingers, they just happen to have pseudo-stingers with the same sting, just without the venom. Oh, and this venom, particularly that of the Pogonomyrmex maricopa, is the most potent venom produced by any known genus of insect. That's right, not bees, not wasps, not spiders. A species of ant is out there in the millions with a neurotoxic, cytolytic, hemolytic, tissue-penetrating, metabolically disruptive venom about 35 times more potent than that of a western diamondback rattlesnake, respective to size, of course. For some perspective, an ant of this species can take down a 2-kilogram rat with just about 12 stings. Fortunately for us chunkier vertebrates, unless it's a severe allergic reaction, harvester ant venom is not life-threatening. If you happen to get bitten, you'd likely just end up with some intensely painful swollen welts that'll itch for a few hours at least. But I digress. This episode is not about ants, it's about a lizard. And the Texas horned lizard is a very accomplished insectivore, and a long-time contender in the co-evolutionary arms race between lizard and ant. They've even developed some specialized adaptations that allow it to effectively and safely snack on venomous ants. Like the other iguanian lizards, horned lizards have prehensile tongues, meaning that these tongues are capable of grasping. Specialized musculature and collagenous tissue allow lizard tongues to be projected and retracted at incredible speeds. But it's not as simple as shooting their tongue in the general direction of an ant. Texas horned lizards use a lot of visual input to judge the timing and the direction of tongue protrusion. What's more, they can even change the trajectory of the tongue mid-tongue protrusion by moving their head based on the movement of their target. Processing this much visual information and making changes on the fly is just so wild to me. And it gets even more impressive. These tongue strikes are sharper and more precise than they seem. Research indicates that Texas horned lizards appear to aim their tongues specifically at the ant's midsection or mesosoma, away from the head and the rear, likely to avoid those mandibles and stinger. And when an ant has been successfully grasped, the tongue pushes the ant into the substrate very briefly before retracting the ant in a rolling motion, keeping the ant from bending its head or abdomen far enough to bite or sting the lizard's tongue. Oh, and also, Texas horned lizards don't bite or chew their ants. Instead, they quickly move the ants past the oral cavity and release them into the pharynx as the tongue retracts in one swift motion. However, that does mean that the ants are still alive, unrestrained, and now capable of biting and stinging again. Not to worry though. The pharynx and the esophagus of a horned lizard is unlike any other iguanian, and designed specifically to incapacitate their very dangerous prey. The pharynx is lined with long papillae densely packed with column-shaped, mucus-producing cells. And these papillae extend from the back of the tongue over the larynx and the trachea along the bottom of the pharynx. And just as the esophagus begins, these papillae abruptly stop and are replaced by deep longitudinal folds that run all the way to the stomach. Each of these major folds is made up of several smaller branching pleats which are coated in more goblet cells that release mucus into the grooves between them. So basically, once an ant has been dropped off by the tongue, it gets completely smothered in mucus from the pharynx all the way to the stomach, making it a lot harder for it to sting or bite anything on the way down. Now, this mucus may have another function outside of packaging food items. Snagging one ant is light work for a Texas horned lizard. But casually munching your way through the ant colony without getting swarmed is an entirely different challenge. Harvester ants have mandibular glands that produce an alarm pheromone. And if that pheromone gets picked up by even one or two ants, the lizard can expect a whole colony to come charging in for a mobbing. Scientists suspect that this copious application of mucus on the ants may delay or suppress the chemical SOS from alerting the colony. And even if a Texas horned lizard makes the mistake of triggering an ant mobbing, its blood contains a plasma factor that can neutralize small doses of the harvester ant venom. While scientists are still studying the composition and how this plasma factor works to neutralize the venom, it's just effective enough for the Texas horned lizard to tank a few ant stings without fatal consequences. Before skedaddling, of course. But these clever lizards never stick around long enough for the ants to catch on. Texas horned lizards will move between several colonies during their foraging period, giving each one time to recover their numbers and avoid any defensive response from the ants. And while they're bouncing between ant colonies, there's a chance that they meet some competition. Horned lizards are very much solitary creatures. They show very little territoriality and practice voluntary mutual avoidance. And outside of mating, the only time they're likely to interact with another lizard is during mealtime. And when two lizards cross paths, they've got a couple of options. They can respect territorial boundaries and preemptively peace out and find a quieter spot. Or they can size up their opponent, raise and wave their tail in warning, and throw hands. And this latter option gets intense. Horns and claws come out as they try to flip each other over and land a hit to the exposed throat or belly. It's quite the production, but one rarely observed in the wild. What's more common though for the lizard is unfortunately a run-in with something looking to eat them. They're not the best at running away with their short legs and wide bodies, so they stick close to vegetation and rely primarily on their camouflage to stay hidden from their many predators, which can include canids like coyotes and foxes, reptiles like rattlesnakes, sidewinders, whip snakes, corch whips, birds like prairie falcons, American kestrels, loggerhead shrikes, red-shouldered hawks, and even roadrunners. If a Texas horned lizard gets spotted or feels threatened, its first move is to flatten itself against the ground. They may even make a short dash, freeze, and try to blend in again somewhere nearby. If a predator gets too close for comfort, they can puff themselves up, making their spikes stick out even more and turning themselves into a much harder meal to swallow. And if all else fails, primarily when dealing with canids, they'll pull out their most famous defensive trick. Just as Mr. Wile E. Coyote gets a little too trigger happy and starts making unwarranted physical contact, the Texas horned lizard will forcefully expel a stream of repulsive blood from its eyes. Yeah, whoa. Now this defense mechanism is set in motion when the lizard closes its eyes and increases the pressure in portions of its internal jugular vein, as well as filling the circumocular blood sinuses by contracting their internal jugular constrictor and protrusor oculi muscles, basically creating near aneurysm-inducing blood pressure and swelling around the eyes. Then the lizard fully constricts the muscles of their eyelids, ejecting the stream of blood at the offending predator. Now, there is evidence that the ejected blood may contain plasma compounds that the canids just find absolutely disgusting. But the identity of those compounds and how they work remains an active area of research. Regardless, if I were a coyote, this little interaction would absolutely ruin my day. I would go home and tell my coyote wife I'll sleep on the couch tonight. But most animals in the wild show more perseverance than I've been blessed with. While initially recoiling, most canids will go at the lizard again. This time, steering clear of those nasty head spikes, that blood-shooting eye, and aim for the raised tail instead. But wait, that's exactly what the Texas horned trickster was hoping for. If you have ever seen a dog play with a tug toy, you know they'll grab it and fling it without a second thought. And that chaotic toss might just be the lizard's ticket to freedom. Once tossed, the canids often lose track of the lizard and off goes the lizard to terrorize another ant colony. While all this ant hunting and predator dodging is going on, the Texas horned lizard also has to find time for some loving. Their breeding season kicks off right after hibernation, running from mid-April to mid-June. And when it starts, the boys are on the move, covering more ground in the first month looking for the ladies than any other time of the year. And when a male comes across a receptive female, it will break into a signature head bobbing routine. Up, down, up, down, up, down, in hopes of expressing his interest. If the female doesn't wave her tail or stroll off, he's going to get really lucky with the pair doing the do, and the do in this case is a type of amplexus, which isn't common in lizards at all. Amplexus typically refers to a reproductive behavior in which amphibians engage in external fertilization. But for our lizards, amplexus just means a mating embrace, and it sounds very steamy. Hear me out. The male grasps the female's shoulders with his forelimbs, climbing onto her back, careful not to get snagged on her large spikes. He'll then hold this position for several hours, biting the largest horn on her head for stability. This is when the hemipenes and the cloaca get involved. But that's a conversation you should probably have with your parents. And that's also about as far as the romance stretches. After amplexus, the male will ghost the female and go on about his day like they didn't even amplexus together, while the female will reject any other mating attempts from suitors. Female lizards breed only once a year, while the mating records of the males are pretty much unknown. I like to think they get around. About a month and a half later, the female Texas horned lizard will start digging a tunnel, and in the quiet safety of the night, she will lay her eggs. This whole process can take anywhere from about 5 to 10 hours, with the mom hanging around just a few more hours afterwards before taking off. Zero parental responsibility after that. In another 1 to 2 months, about 23 little itty bitty lizard babies will emerge from the tunnel, completely independent, with their sex determined by the temperature they experience while developing in their eggs. Just like their parents, the hatchlings are skittish little things, especially because they don't have all their spikes yet. They'll run from any sign of danger, even their soon-to-be favorite snack, the harvester ants. But as the babies mature into the summer, they'll grow out their armor and pick up a few more life skills, like standing very still when evading predators, and eventually graduate into invading anthills. But that is not their most immediate challenge. The coming months are some of the driest and hottest of the year, which means that these hatchlings will have to figure out some way to stay hydrated. Now, finding water may not be the easiest thing to do in the desert, but several lizard species living in dry environments have evolved a remarkable skill to actually collect water from any part of their body. This adaptation is called moisture or rain harvesting, and it allows these very special lizards to gather up and passively transport water from all kinds of sources like fog, dew, rain, or even just damp soil. Texas horned lizard bodies are covered in microscopic channels that run along their body from tail to snout, directing moisture collected at any part of their body towards their mouth. And two key features make these channels extremely effective at their job. The first of which is that the channels are wider in the direction of the tail and narrower towards the mouth. What that means is that the meniscus of the water becomes more concave the narrower the channel gets, thereby also increasing the capillary force, moving the water towards the mouth. The second important factor is that the way these channels form an interconnected capillary network. So if the water gets stuck or slows down in one channel, it's quickly picked up again by water moving through a neighboring channel. Now, this system is so incredibly efficient that scientists are even trying to replicate their own passive directional liquid transport systems in plastic. So where do we leave our lizards before I went off about plumbing? Alright. Come October, if the hatchlings have successfully evaded the predators, harvested the rain, and fattened up on ants and other insects, it's time for them to dig their own tunnels and settle in for winter hibernation. And every Texas horned lizard that survives another year in Texas is a little victory worth celebrating. Between the late 1960s and 1970s, Texas experienced its largest decline in Texas horned lizard populations, with lizards disappearing from at least 30% of its historic range. While a lot of factors contributed to this decline, including invasive species, habitat fragmentation, the pet trade, many organizations like the San Antonio Zoo, Texas Parks and Wildlife Department, Fort Worth Zoo, the Horned Lizard Conservation Society, are working with private landowners and other conservation partners to help bring this much-loved species back to where it belongs. Long live the spiky pancake! A special thank you to the many scientists and grad students that got nasty sunburns looking for lizards out there in the desert, or spent way too long in the lab producing and sharing their horned lizard research. In case you'd like to read more about the information I shared on this episode, I've added a list of references in the description. And thank you for hanging out. I'm blessed that you're here. If you're celebrating your birthday today, a very happy birthday to you. And if you're going through a rough patch, I wish you nothing but happiness. But if you're just out there, just having a day, I'd like to trouble you for a like, a subscribe, or even a little story about your favorite strange animal. I'll see you again soon. Peace.